Hey, what's going on, guys? Games here. In this video we're going to learn how to convert x86 assembly add instruction to x86 machine code. Okay, so let's start by adding an immediate data to AX. This is the special case, and here we have the add AX. So in this case we use the opcode 05. Okay, so I say 05, and then to encode the data not like this, because this is the big endian, while the x86 architecture uses the little endian byte order. So this is going to be encoded like so. And now let's check this out using NASM. So we have 055588, which is correct. Okay, now let's move further on. So the next thing to do is to add a constant value, the immediate data, to the register. Okay, so immediate data to the register add. So we use this encoding for an opcode. Okay, and then here is the instruction format. Okay, immediate to register. Okay, and put it here. So how to decode this part? So we need so this is the decimal value. We need to represent it with 3 bytes, and then W would be 1 if we're dealing with 16-bit registers or bytes or words. I mean, otherwise with the 8-bit registers or with bytes, this should be equal to 0. Okay, 11 is mode, telling us that we're dealing with the registers or immediate data, so it's not about the memory. Okay, now this question mark. So question mark, so we have add here and we have add here. So the question mark value for add is 0000. So just replace this with 3 zeros. Now the register is DH. So let's find the DH in the table of the registers. 110, 110, and the data is 05 hexadecimal. Now 8 is also hexadecimal, and this is binary. Now let's align the bits to have 4 in the one chunk. Okay, so this is binary and this is binary, and the instruction would be 8 0. This is C, this is C, 6 and 05. So let's check if this is so. Yeah, let's just uncomment the first one to avoid getting distracted. So 80C605, C605, which is correct. Great. So let's move further on. Now we want to add an immediate data to a byte at memory. So how we can do that? Okay, so we use the same opcode encoding here, but here we have a slightly different format for an instruction. Okay, so question mark, so it would be 0000, just like we had previously for this add. So everywhere you encounter this one, you need to replace the value for register. Okay, so this is the mode, which means that we're dealing with the memory. This means that we're dealing with a direct address. So this is the address on its own, and if we have a look at the address, we have this 01F0 address. So 01F0, but this is, we need to turn to the little endian, so it would be like this, and then the data itself is 05. So yeah, and I forgot to turn this one 8-bit, hence 0, hence 0. So this is hexadecimal, this is binary. Okay, this is binary. All right, this is binary, this is hex, this is hex. So 8006, yeah, F001 05. So let's check if this is correct. 8006 F00105. Okay, great. So the next thing, we want to add two registers, and the result would be stored in the AH, in the destination register. So how can we add two registers? So here it is. So 3 here. Now the opcode is changing. So we have this one, and this is the format for instruction. Okay, so W is equal to 0 because we're dealing with the 8-bit data. We're gonna be dealing with a well, let's probably make it like no, not AX, because we have a special case. Let's say DX and CX for instance. So just to make it a bit different. So now W is going to be equal to 1 because DX and CX are 16 bits. So no memory. We're dealing with the registers, and now to encode the register, to encode the registers. So first encoding the source and then the target. So it's not like it's done in assembly. In machine codes, we have source and then destination. While in assembly, we have destination and then source. So source CX 001. So here I replaced with a 001, and DX 010. So here I replace with 010. All right. So this is hexadecimal, this is binary, so align the bits, this is binary, and this is binary. So eventually we have 0, 1, C, and A, right? So let's check this out. Okay, 0, 1, C8, which is correct. Awesome. So let's move further on. Now we want to put value from BX to a certain the memory at the location of the memory. So how can we do that? Register to memory. So 4 here. No, hold on a sec. Yeah, the opcode is still the same for encoding for opcode is still the same for now. So 4, and this is the instruction format. So W is 0, no, W is 1 because we're dealing with 16-bit word, or BX is 16-bit as well. The register BX 011, so 011. And now let's align the bits. So this is hexadecimal, this is binary. Okay, this is binary, and this is binary, and the address is F001. Address is always the same. I did it just for clarity, basically, so just to make it easier to deal with addresses. So we have 0, 1, 1, E, F001. So this should be our code. Let's have a look. 011 E F001. Yeah, which is correct. Okay. And the very last but not least is how to put the value from the memory at the given address to the register. So let's go for that as well. So here the opcode would change. Okay. And the format respectively is going to be this one. Copy and paste. So 1 in binary would be 001 with a take involving 3 bits, and W is going to be equal to 0 because we have DH is 8-bit, byte is 8-bit. Okay, now the value for DH is 001, and the address is F001. Now let's align the bits. So binary here. Okay, and we have 0, 2, 3, 6, and F001. All right, so let's run to make sure it's okay. 2, 3, 6, F001, which is okay, which is correct. Awesome, guys. So now I'll just uncomment all the values, and we have all the opcodes being assembled, and they exactly match to those we came up with by hands. So this is it from my side, guys. I hope you learned something interesting out of this tutorial. Thanks for watching. Until the next time, and take care.